like to take a moment now and explain a little bit about Azure Networking, kind of help you visualize how it works. So Azure Networking is really not too different from our real on-premise network. On-premise, we have TCP/IP based networks. We have equipment that allows us to handle IP addressing, such as routers, and with the help of switches, we can connect our computers together, or wireless access points or whatever. But ultimately, our routers are going to allow us to transmit information across the network and communicate with network adapter cards utilizing different subnets. So in TCP/IP, we have an address space, a certain set of IP addresses, and we can break those IP addresses up into different subnets. Well, the same kind of thing happens in Azure. So I want to talk a little bit about that with you right now. So the first thing that you have in Azure is you have what is called a VNet. A VNet is a block of IP addresses. So for example, I might call this VNet 1. All right, and the address space for VNet 1 might be, we'll say, 10.1.0.0/16. Now, I'm not here to teach you TCP/IP subnetting here. You kind of expected to understand a little bit about subnets coming into this, but the idea of TCP/IP at least. If you do the math on that, you would get 65,536 possible combinations on that total address space right there. Okay, because these two zeros in binary would be 16 bits, 2 to the power of 16. That's where you're getting the number. All right, but that would be the whole address space. All right, as a whole. From there, I could break this into subnets. Okay, and so I might have a subnet here. Let's call this subnet. I'll call it V subnet 1, and I would give it 10.1, we'll say .1.0/24. Now that would actually give us 254 combinations, although Azure does reserve a couple of the IP addresses for itself. But that would be that subnet right there. And then I could create, another subnet if I wanted. This could be subnet 2, V subnet 2, 10.1.2.0/24, and that would give me 254 roughly addresses for this subnet. And then same thing here, I could create another subnet here, just to kind of go along with the same strategy here. We'll say this is V subnet 3, 10.1.3.0/24. And then just to cap it off, we'll create one more, and that will be our fourth and final one listed here. All right, and so that will be subnet V subnet 4. All right, 10.1.4.0/24. Okay, and then so from there, I now have one VNet, and I have virtual subnets between that are part of that, and I could create virtual machines, and I could place them. Remember that virtual machines have what are called virtual NICs, VNIC. Okay, which I'm going to outline in green here. And the VNICs would be connected to your virtual machines. And your virtual machines, the VNICs would then be connected to the subnet. And at that point, you could have different virtual machines on each one of the subnets if you wanted. You could have some virtual machines on the same subnets if you want. By default, routing in regards to VNets is automatic. That means that any subnet that is part of the same VNet, routing is automatic. That means that this subnet can communicate with this subnet and vice versa. They can all communicate with each other because they're part of the same VNet. Now, you can also police traffic on VNets as well using something called an NSG. An NSG is a network security group. A network security group allows you to do what's called packet filtering. So I can block inbound or outbound traffic if I want. NSGs can either be placed directly on a subnet or directly on a VNIC. That's it. You can't attach it to the entire VNet. You can attach it to either the subnet or the VNet itself. The VNIC itself, sorry, the virtual network adapter on a machine. So NSG is going to let you police traffic inbound and outbound for either a network, a network adapter card, network or the VNIC, or the actual subnet itself. Okay, so that is the idea of what a NSG does, and you can pretty much create as many of those you want. The good news is this doesn't really cost any money. As you're working with VNets and virtual subnets and all that, Microsoft isn't charging you for any of that. Okay, obviously virtual machines and all that's going to cost you money, but NSGs and VNICs and subnets and all that stuff doesn't really cost any money. So you can also, with the help of that, you could, you create one VNet, but you could create multiple VNets if you wanted to. So I could have more than one VNet here. So let me just expand my drawing a little bit here, and let's go a little deeper with it. So I could go down here, and I could have, we'll call this VNet 1, and it's 10.1.0.0/16 is the whole entire thing. Okay, and then maybe I've got, let's move this over here, and then maybe I've got, let's say, 3 other VNets, like so. This is another option, another way we could do it, 10.2.0.0/16. That's going to be the address space there. Move this up a little bit. All right, move this down a little bit. Okay, and this will be, we'll say VNet 3, 10.3.0.0/16. And this will be VNet 4. So these VNets, if you wanted, you could have different virtual machines that have different jobs involved. And in fact, this is actually a pretty common scenario. This is known as a hub and spoke. This VNet being like a hub type of scenario, and these being spoke VNets. And then the other thing that a lot of companies will do is they'll have like the internet connection. This little cloud here gonna represent my my internet connection. Let me just kind of clean that up a little bit. All right, the internet connection, you're going to have what's known as a public IP address that connects out to everything, right? So if I want, I've got, I could set up what is known as a virtual firewall. Azure supports virtual firewalls, and I could set up a virtual firewall here. And then of course we've got a public IP address, also known as a PIP, a public IP address that gets us out to the internet there, and you could connect the VNets all together. Now I will say this, subnets like here are all connected together if they're part of the same VNet, but VNets themselves are not connected together. You actually have to do what's called VNet peering. So we can peer these VNets together if we want by using what's called peering. Okay, but that doesn't happen by default. You have to enable that in Azure. So we might do peering here, and that way we can control traffic, and we can make it where, let's just add some virtual machines here. Maybe we got some virtual machines here. All right, and I didn't specify subnets, but we could say that this is going to represent a subnet. This is a subnet, this is a subnet, this is a subnet. And from there, we could make it where to get out to the internet, these virtual machines have to go through the firewall and out. And then things coming in have to go through the firewall in. We could even set up a load balancer and all that. Another thing is we could have, an on-prem network here. On-premise. Okay. Actually, I need to move that over there because that's where the internet is, isn't it? Let's shrink this down a little bit. Okay, so you have an on-premise network. The on-premise network is connected to the internet. And then what you could do is you could also set up what is called a VPN gateway. And the VPN gateway, let me just make that orange here. The VPN gateway is a way in which you could connect, you can establish a connection through the internet into your on-premise network. And so your on-premise network can have a direct connection into Azure and communicate. That's one way you can do it. Another way you can do it is you can do what's called ExpressRoute, where your company works with a service provider, and that uses a very high-speed connection directly into Azure itself. So VPN Gateway, ExpressRoute, which we don't really get deep into this course at all on what all that is, but you can research it a little bit, and those are options that you could use for connecting in. But ultimately, hopefully that gives you now a good visualization as to what VNets are, subnets, the concept of peering, and the fact that we can control the flow of traffic with NSGs, as well as when we're connecting our VNets together, allowing them to go through a hub and spoke type scenario. This being the hub, these being spokes. And I would say that's a pretty common strategy that people use. You could even utilize a load balancer if you wanted. So you could implement what is called a virtual load balancer if you had like a bunch of web servers or something set up. So let me just show you what I'm talking about here. Let's copy this. All right, let's say that you have, let's say that this is going to represent 3 web servers. Okay, you could actually have a load balancer where when people connect in, they first have to connect through the firewall. Okay, and then the firewall transitions them. Let me use this. Hold on. So they first connect into the firewall. The firewall transitions to the virtual load balancer, and the load balancer would then load balance the traffic going between the different virtual machines. So this is also very common in dealing with things like web servers. But hopefully that now gives you a good understanding of at least the visualization side of understanding Azure networking.
This is John Christopher. I hope you enjoyed that video, and I want you to know that I'm trying really hard to grow this channel, so I hope you'll give me a like and a subscribe. Also, if you'll check the description in this video, I've got a link for you that can show you how you can get access to all my different courses. I have lots of different Microsoft certification courses that'll help you pass your exam. All right, thanks a lot for watching the video, and I hope to see you again.